Hey everyone, welcome back to another online lesson with your favorite teacher of all time. So hopefully everything went well last week. There's a few people that are having some issues with submitting assignments. So if you're having any kind of issues, maybe first thing you want to do is just do a quick Google search just to make sure that you understand how to do it properly on Google Classroom. And then worst case scenario, you can also submit your work through Edsby or directly to my email. But most people are doing a really good job. There's a couple late submissions, which is okay. I understand that you guys are working around, your parents and siblings, and life is kind of crazy and unpredictable right now. So the main thing is as long as you're getting your work done and submitted, I'm okay. But let's try to do our best to stick to deadlines. So this week we're going to be looking at the effects of outliers on averages, and we'll go into a little bit more detail about what an outlier is specifically. We're going to be talking about the applications of averages. So when do you choose to use mean versus mode versus median? Because there's certain circumstances where you want to use over the other ones. And then for our to-do list for this week, so we have the homework book. So that's exactly what I would usually print off for you guys in class. So I'm thinking that will take probably about an hour to get through. Textbook questions for 7.3, 7.4, that should also take about an hour. And keep in mind, when I'm thinking about these timelines, I'm thinking about like an hour of dedicated work time, not like an hour of like, oh, I'm watching Netflix or I'm on YouTube simultaneously as I'm working. I'm talking about like you're sitting down in a quiet place, at a desk, at a table, and you're focused on doing your work. Third thing, I've created a Google form. I'm calling it Check Your Understanding. It's basically a Google form where you can input all of your answers from the homework book, and then at the very end you hit submit, and then it'll give you a mark. So that is a good way to sort of keep track on how you're doing, and sort of allows you to see, okay, these questions I didn't understand, these ones I got, and then based on that, you can actually write down some stuff. So maybe you're having some issues with the application of averages or whatever it may be, and then you can write that down, and then during the video chat, we can talk about that. After that, there is the mid-unit review. So this is the one that's taken out of the textbook. It should be about an hour to do that. And then at the very end, we have our online quiz. So it's through a website called Quizzes, and that should take about 30 minutes. So all in, we are looking at 1 hour, 2 hours, 3 hours, about 4 hours, give or take. So we're kind of building up towards our 5-hour mark that we're supposed to be reaching every week. So maybe next week there'll be a little bit more. And this is all going to be due on Friday the 25th. So I have released all of this stuff on Monday. So it'll be up to you on how you're going to determine what you're going to do and when you're going to do it. And I think that's going to be really helpful for some people that have to share a computer with siblings or parents. So just make sure that everything is done by Friday. If you're a keener, you can get it all done in one day. Or if you want to break it up and just do maybe half an hour every single day, or just break it up in however which way you want, you're welcome to do that too. All right, for 7.4, we're gonna have a look at a question. So this question is related to heart rate over daytime activity. So I've created a graph to show this relationship. So on our y-axis, we have our heart rate in beats per minute. So that's how many times your heart rate beat in 1 minute. And then at the bottom here, we have hours. So this to 7 in the evening. So let's have a look at our data first. So within the first hour, heart rate is about 60 beats per minute, up to 80 beats per minute, and again at 80 beats per minute, down to 70, down to 60. So this is 1 and 2 in the afternoon. And then at 3, well, it spikes up all the way to about 180 beats per minute. And then looking on 4 o'clock, 5 o'clock, we're at about 80 beats per minute there. And then towards the end of the recorded time. We're down to 70 beats per minute and then down to 60. So what I've done is I've recorded all of these pieces of information. So this is how many pieces of information I have. So I have a total of 13 pieces of information, and this is the sequence that it's recorded in. So 60, 80, 80, 70, 70, 60, 60, 60, 180, 80, 80, 70, 60. Then what I've done is I've rearranged it in ascending order. So I have 60, 1, 2, 3, 4, 5 times. I have 70, 1, 2, 3 times. And I have 80, 1, 2, 3, 4 times. And then I have my 180. So looking at this data set, which one do you think applies, or which one do you think is the outlier? So looking at a definition here, so an outlier is a number that is significantly different than the rest of the numbers in a data set. So the number that is significantly different would obviously be 180, because it's not anywhere near the rest of our data. So if you have a question that's asking for the mean, median, and the mode, we're going to see how the outlier actually impacts our data. So to find our mean, what we need to do is we need to add up all of our numbers, all of our data, and then we need to divide by the amount that we have. So I've already gone ahead and done that. So by adding up all the numbers that we have here, it gives us 1010, and we're going to divide that by 13 because that's how many pieces of information that we have. So that would mean that our mean heart rate is 77.69 beats per minute. But we're going to have a look and see how our outlier impacts our mean. So over here, I've taken 1010. I've subtracted our outlier, so I've gotten rid of the 180, so that equals 830. So I'm going to take 830 divided by 12 because I've taken away one piece of data. So now I have a total of 12. So that's going to equal 69.16 beats per minute. So that's without the outlier. So by having that one piece of information, that outlier, it has actually had a fairly significant impact on our mean. So looking at our median. So in this column that I've created here, I have figured out what our median is. So that's our middle number. So we have 13 pieces of information, and then counting up and down allows me to find the middle. So if I count from the top down, 1, 2, 3, 4, 5, 6, and then counting up from the bottom, 1, 2, 3, 4, 5, 6. That leaves me with one middle number here, which I've starred, which is 70. So my median would be 70. So which of these two numbers, which of my means is closer to my median? Well, it's the one without the outlier. So 69.16 is a lot closer to 70 than 77.69. So you'd actually probably round this up to 78. So the median is probably the best way to represent our average here. And then what would our mode be? Well, looking at our set of data here, which one occurs the most? Well, it's 60 because it occurs 1, 2, 3, 4, 5 times. So if someone were to ask you, well, which one would you use? Would you use mean, median, or mode to represent the average heart rate for this person's day? So looking at our data here, which one would you use? Would you use mode just because your heart rate has been at 60 beats per minute the most? Well, maybe not. Would you use the mean including the outlier? Not necessarily, because that outlier sort of skews our information. So in this case, I would want to use the mean without the outlier or the median, because they're relatively close to one another. Okay, so we have another scenario. So what is the average size that is sold? So I have shirts, I have an amount. So we have 5 extra smalls, 7 smalls, 10 mediums, 10 larges, 6 extra large, and 1 extra large. So we need to be able to calculate the mean, median, mode with and without the outlier. So pause the video and then do the question and then come back for the solution. So first thing that we're going to do is we're going to calculate the mean. And what we need to do is add up all of our numbers here and then divide by the amount that we have. So we're going to go 5 plus 7 plus 10 plus 10 plus 6 plus 1. So that equals 39. And we're going to take 39 and divide by the amount of options that we have. 1, 2, 3, 4, 5, 6. So 39 divided by 6, that's going to equal 6.5. So that is our mean. So first thing that we're going to do is we're going to calculate the mean. And what we need to do is add up all of our numbers here and then divide by the amount that we have. So we're going to go 5 plus 7 plus 10 plus 10 plus 6 plus 1. So that equals 39. And we're going to take 39 and divide by the amount of options that we have. 1, 2, 3, 4, 5, 6. So 39 divided by 6, that's going to equal 6.5. So that is our mean. Now for our median, let's see what our middle number is. So median. So we have 6 numbers, so we're going to have 2 central numbers. So first thing that we need to do is take this and then arrange it in ascending order. Okay, so I've taken my numbers and I've put it in ascending order. So 1, 6, 5, 7, 10, and 10. I don't have a true central number because I have an even amount. So I'm going to take 5 and I'm going to add that to 7. So that's going to equal 12. I'm going to divide by 2 because I have 2 numbers. So that's pretty easy to do. 12 divided by 2, that equals 6. So our median equals 6. And then the last thing that we need to do is find our mode. So our mode is just the most frequently occurring number. And we can just have a look here. So obviously that's going to be 10 because 10 occurs twice. Now we've done all of these calculations, obviously including the outlier because we didn't remove any piece of information. But looking at our quantities, which one do you think is the outlier? If you chose 1, you are correct. So it's the most significantly different number from the rest of our data. So now we're going to quickly do the calculations when we remove the outlier. So this is my calculation of the mean without the outlier. So 5 plus 7 plus 10 plus 10 plus 6 equals 38. I'm going to take 38, I'm going to divide by 5 because now that I've removed the outlier, I have 5 pieces of information. So that gives me a total of 7.6. For the median, I just take my new set of numbers without 1. So I've removed the outlier. And all I need to do is to find that central number. So in this case, it would be 7. And then the mode is still the same because 10 occurs the most frequently. So now that we've done all the work, going back to the original question, what is the average size that is sold? So we have some information to sort of pick through. So our mean with the outlier is 6.5 shirts. With the outlier removed, it says that we have 7.6 shirts that we sell on average. If we're using the median with our outlier, it says that we're selling 6 shirts. And then the median without the outlier is saying that we're selling 7 shirts. But what's one thing that hasn't changed? Well, that's the mode. So the mode stayed the same for when we both had the outlier and didn't have the outlier. And just looking at this specific type of question, it doesn't really make sense to say that, hey, we need to order 6.5 shirts because, well, we can't order half of a shirt. And it doesn't really tell us which particular size that we need to order. So that's not very helpful information using the mean with the outlier. Neither is it very useful to calculate the mean without the outlier. So can we order 7.6 shirts? No. Is it telling us what sizes that we need to order? No. But the mode is telling us that, well, the ones that have number 10 next to them, well, they're being sold the most frequently. So if we needed to order more shirts to sort of restock our store, chances are we're going to want to order medium and large before we order extra large, extra large. Smalls would probably be our second priority, and then extra smalls. All right, to wrap everything up, let's have a look at our outlier again. So an outlier is a number in a data set that is significantly different. And sometimes you want to ignore them. So for example, if you're a scientist and you're measuring something and you make a mistake and you know that you made a mistake, obviously you're going to throw that piece of information out because it's going to throw off your results significantly. Sometimes you'd include it if it is a relevant piece of information. So next up, we're going to look at when you should use mean, median, and mode to find different averages. So the mean is usually the best average when no number is significantly different. So for example, class grades. So if everyone in the class has a mark between 75 and 100, relatively speaking, from 0 to 100, they're fairly similar. So what I would do is I would take all of the students' grades and then add them up and then divide by the amount of students. And that would give us a class average. Whereas the median is usually the best average where there are numbers in a data set that are significantly different. So my example here, I have rainfall. So if you're going to measure the rainfall in Calgary for the month of April, there's going to be some significant differences. So there might be some days where it rains, I don't know, upwards of say 50 millimeters. And then there's going to be probably half the month where there's no rainfall. So in this case, you'd want to use median to find that middle number. And the last one here, the mode is usually the best average when the data represents measures. So in this case, that kind of goes back to our t-shirt example where we had small, mediums, and larges. That sort of takes care of 7.3, 7.4. If you have any questions, make sure that you have a look at the teacher contact schedule, and then we can get together either for the Q&A sessions where you guys can send me messages and I'll try to get back to you as soon as I can, either through Edsby or Google Classroom, or you can connect with me through Google Meet during our chat times. Other than that, have a fantastic week. See ya.